Hi folks, back earlier than expected here. I wanted to just touch base again here because I've actually refined his course a little further. I made a bit of a mistake in the first part in the angle on bow, I believe, because it actually took us a little longer to get to a 90-degree angle on bow than I had anticipated. Therefore, I had his course estimated at 103. It's actually closer to about 0.95 or so, and that actually, and I should have realized this at the moment, but that actually represents a little better faring of his plot points than before, and that actually, based on our matching course and speed, this actually does approximate his speed as well. This particular course line. And so you can see 1207, I did a couple of interim checks here. 1207 minus 1114, that is a time span of 53 minutes, plus some change. The 56 here is at 6 knots from the first bearing line to the last bearing line here on a course of 095. So you can see that at an even 6 knots, that would have taken him 56 minutes, when in reality, if we were to use decimals, of course, a time of 53 minutes would put him about just a hair over 6 knots, which is pretty consistent with what when we did our matching course and speed at 6.3 knots own speed, that bearing was barely changing. And so 6.3 is a pretty good approximation of this. I think going forward, and this would be a recommendation to you, I think, is to really just deep six this method here altogether and use a time speed distance calculation. For example, if you look on the Wolfpack forum itself, I can't remember what thread, but Alfaba had posted the actual formula to use to get the actual time speed distance formula to use, particularly in converting between nautical and metric, to dial that in further. I myself am going to use that going forward, and I would maybe suggest you do that as well, because that actually is part of why I had the incorrect course line there, because I did not adjust it to get more of an exact speed based on our matching exercise. And so based on angle on bow that I observed at this particular bearing here and this bearing here, at that previous course line of 103, that it just wasn't lining up correctly. So moral of the story here is make an estimate of an angle on bow at every bearing you take, along with the ranges. That's the first takeaway. B, get your course line fared better than I had. Take those. This is why it's helpful maybe as you're going along at some larger interval like this, for example, while you're overhauling. It's helpful to just to get a couple of interim bearing checks, so that you're not wildly off base. And God help us if the targets in this game ever are coded in such a way that they actually have zigzag patterns built in. Then you better be on the ball in terms of watching that target's angle on bow at every bearing to be able to detect any course changes that he might make. So it's just a good habit to get into, to estimate angle on bow as you make observations, and then either using the protractor. So for those of you who aren't aware of how to do that, center it. If I want to take the angle on bow at this particular observation, compare it, I had pressed the space bar. That sets me to the snaps to 0 mark to my line, and then I just line up that line with the course line, and then read off the angle on bow, which in this case you can see intersects with the bearing line at about 74 degrees, which is the angle on bow there. So so that is that's a good thing to do, is check that as well. So get his course line fared, check his angle on the bow, you know, make sure you get a good speed estimate for matching if you can, and then further refine that course line in conjunction with those other things. So just figured I'd since I've made an update while I'm plotting here, figured I'd touch base again, and when we reconvene here, when I'm ahead of him, you'll notice that the course has been changed. Now, hopefully I'm not wrong again here, but we'll see what happens. So anyway, catch you in a few.